Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of simple and compound probabilities. This is standard 7.6i in the great state of Texas, and we are using item number 25 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've got a number cube or a die, standard. It's got faces labeled 1 to 6. It was rolled 20 times, and so we've got this frequency table here showing how many times 1, 2, 3, 4, 5, and 6 showed up. So based on these results, that's going to be very important in just a moment. What's our experimental probability that the next number cube rolled? It will be 5 or 6. So this is what we call a simple event because there's just one possible outcome, one thing happening, rolling a die and seeing whether it lands on a 5 or a 6. That's a simple event. If we wanted a compound event, that would be if we were to string some simple events together, like what's the chance of rolling a die for it landing on 5 or 6, and then rolling it again and having it land on a 2. So that would be a compound probability because we're getting at least 2 simple events stringed together. Now this is what's interesting because it says based on these results, because these results, if you notice, are a little bit skewed. Look at that. 4 lands 6 times, 6 lands 5 times, and 1 lands not at all. It never lands. Out of 20 rolls, it never lands on 1, and that's where your probability is always going to be different than what actually happens. So this experimental probability is taking these results and thinking what might happen next, as opposed to just the theoretical probability. So let's take a look at that to see how it differs. Theoretical probability is not what actually happens, but what should happen in a perfect world if everything works out evenly. Well, let's see. What is my chance of getting a 5 or a 6, right? So a 5 or a 6. Well, how many of those are there over the total? Well, there's 2 out of 6. And that means we're going to reduce this by 2's. And I'm going to get 1/3. All right, so theoretically, if I don't take these results into account, I've got a 1 out of 3 chance of getting a 5 or 6, because that makes sense. There's 6 faces, and 2 of them are a 5 and a 6, which is what we're looking for, but we're not looking at that theoretical probability. We are looking instead at this experimental probability. So that's the difference. Let's label that experimental probability. All right, so instead of this 5 or 6 being just 2, we need to actually take a look at our results. We're still going to use this fraction. Fractions are still a good way to show this here. But what are the chances of getting a 5 or 6? Well, that's going to be a 3 and a 5. So that's 3. We're going to add these two. Since it can be one or the other, we're going to add them over your total. Now remember, instead of just 6 faces, how many total rolls did we have? We had 20 total rolls, so we are going to need that. They did 3 plus 5. I was putting the answer there already, I guess, over my 20. So that's going to be 8 over 20. And those are both even. We could divide by 4s if we really wanted to. That's going to get you 2/5. All right, so that's going to work for A. You notice here B, we get 3/20. That's if you just take the 5 and exclude the 6, you can get that 3/20. And I'm not sure with that 3/5. Let's see, multiply by 4. It's going to be 12 over 20. Not sure where they got that from. But our answer here is going to be 2/5 A.